Welcome folks. In this video we are going to look at science paper 1 for the year 2017. Here we have a question that was written by the external candidates. Now we'll first begin by dealing with section A of this paper. So let's look at the first question. The diagram below shows part of a ruler used to find the length of a nail. So we can see that the nail is starting from 1 here, then ending up to somewhere at this point here. Then the question is, what is the length of the nail? Now here the trickiness for this question is you don't have to start counting from 1. So what you do is, since the arrangement or the diagram, you can see that the placing of this nail started from 1, so consider 1 as 0. So say if this is our 0, then this one will consider to be our 2, our 1, then here we have our 2. So then we can see that 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. So here the length of this particular nail is 2.7. so that's what you do. The same principle that we use under construction. If you are told to measure the distance of 5 centimeters, you don't start from 1, you start from 0, then you count up to 5 centimeters. If you start from 1, the 5 centimeters will be at 6 centimeters. So that is the pattern there. Now we can move on to question 2. The diagram below shows a block of wood of density 0.6 grams per cubic centimeter. Then we have these 3 dimensions. So our length, this is our length, since it is the longest. Then if this is our length, we'll consider this one as our breadth. Then we'll say this is our height, or in whatever diagram you may take it, the answer will always be the same. So now the question is, what is the mass of the block? So if we have we know that density is equal to mass divided by volume. So if we want to make mass the subtle formula, or for us to find mass, we need to multiply density multiplied by volume. Now we know that the density is what given. So what can we do? We are going to use the 3 dimensions to find the volume. So we are going to say volume is equal to L times B times the height. So it doesn't matter which length will be considered as our length in this particular diagram, the answer will always be the same. So say our length is 5 centimeters multiplied by, we have our breadth 1 centimeter times 10 centimeters. So we know that 5 times 1 is 5 times 10 will give us 50. Then if we multiply centimeter times centimeter times centimeter, we get our volume to 50 cubic centimeters. So here we are going to have our density is 0.6 grams per cubic centimeters times 50 centimeters cubic. So we cancel. Then if we multiply 0.6 times 50, we are getting 30. So here we are going to get 30 grams as our answer. So this is our answer. So under multiple choices, first you need to know the answer. Then here under the multiple choices, you just have to see the answer from the multiple choices which is corresponding to the correct answer according to your studies. You don't get the answers from multiple choices. No, you need to find the answer based on your studies. Then you compare which one is corresponding to your studies. Now we can move on to question 3, where question 3, the diagram below shows a graph of how a distance covered by a woman varies with time as she takes a walk from her home to the market. Now this is a distance time graph. So the way we treat a distance time graph differs in how we handle a velocity or speed time graph. Under velocity time graph, whenever we have a line moving parallel to the x-axis, indicates that the velocity is constant. But for a distance time graph, the case is different. For this one, whenever we see a line, a vertical, a horizontal line that is moving parallel to the x-axis, it means that an object or a person has stopped or is not moving. So that is what is between AB. Then here between OA, here there is movement. So this indicates that this person is moving. AB stopped, then BC continues moving. So this is what we have to know. Then let's look at question. What was happening in the region AB during the woman's walk? So we already know. So A, walked with a constant speed, no. B, walked faster than before. C, walked slower than before. D, stopped walking. So the answer is D. Then for question A4, a parachutist of mass 60 kg falls with constant velocity of 5 meters per second together with a parachute of mass 20 kg. Taking gravity to be 10 newtons per kg, what is the resultant force on the system? So here, this question may seem to be confusing, but I'm sure the concept here is we have this here with a constant velocity. So what happens if an object is moving downward? So what happens is when this object or person is dropped, the acceleration, or say the velocity, will start to increase. Then as that object is falling down, that object will face the air resistance. Now this object will reach at a point where the air resistance equals to the weight, which is the force that is bringing this object down. So at that point now, the object will start to fall with a constant velocity, and we call this one a terminal velocity. So a terminal velocity in terms of a falling object is just the point at which an object is falling with a constant velocity, and at this point we are saying the air resistance, the force that is trying to oppose the movement of this object toward the ground, is equal to the weight. So at this point the resultant force is just zero. So according to my studies and what I've known, at this point the resultant is zero. That's why the object is moving with constant. So there is no force which is greater than the other. So now we can move on to question 5. The diagram below shows a frictionless pulley used to lift an 800 block of concrete. Okay, so then what is the minimum effort required to raise the block? So we know that if we had to calculate the effort, we know the formula is mechanical advantage is equal to load over effort. So we know that we have the load we have been given. The load is 8,000 newtons. So this is our load. Now the question is, how can we find mechanical advantage? But let's look at the diagram. Can we find the velocity ratio? Yes, we can find the velocity ratio. How? By just counting the circles or the number of ropes. So we can see that we have 1, 2, 3, 4. So our velocity ratio for this system is 4. So the same as if we can count 1, 2, 3, 4. Now, if we have velocity ratio as 4, then what is the mechanical advantage? So here, since we have been given this statement of frictionless, this means that there is no, we are assuming that there is no friction. If there is no friction, then we can assume that the machine, this simple machine, is considered to be an ideal. So if this is considered to be an ideal, the velocity ratio will be equal to mechanical advantage. So the same for here will represent the mechanical advantage. So this is what we are going to put where there is mechanical advantage. So mechanical advantage is 4. Then our load we know is 8,000 newtons. Then our point is we want to find the effort. So 4 times E will give us 4E. 1 times 8,000. This will give us 80,000. Then what you do, you divide by 4, also here by 4. So our effort here will give us 2,000 newtons. So this is our effort. So let's look at the multiple choices. So the multiple choices, we can see that our answer is B here. Now let's move on to question 6. The diagram below shows a model of a crane with a counterbalance weighing 200 Newton. This counterbalance can be moved further or closer to 0 to accommodate different loads. Now, what is the maximum load the crane can safely lift? So the key point is here. This is where our key point is. So for us to understand this concept here, we'll consider this. We'll consider this as our moment 1, which is our anti-clockwise moment. Then we'll consider this one as our moment 2. So let's look at let's check if these two moments are equal to each. So we know that moment is equal to force multiplied by distance. So moment 2, our force, we can see that it's 100 newtons. Then multiplied by our distance is 1 meter. So if we multiply 100 by 1, it's the same, 800 Newton meter. So this is our moment on the right side. Now let's check for moment 1. So for moment 1, we are going to have force times distance. So let's look at our force. Our force is 200. Then our distance is just 2. This is our distance here. So if we multiply, we can see that on the left side we have 400 Newton meter. So we can see that these two moments are not equal. So this counterbalance is not in equilibrium. So now the question is, what is the maximum load? So by what number can we multiply by 2 to give us the same moment? So how can we find this one? So let's say this force of 200, let's consider or ignore. Let's say we don't have this force. So if we don't have this force, then we'll say force 1 multiplied by distance 1 is equal to force 2 times the distance 2 for these two balance. Then force 1 is what we are solving for. Distance 2 we know is 2 is equal to force 2 is 800 times 1. So 2 times F1 will give us F1, then is equal to 800. Then if we divide by 2, then also by 2 here, we can see that we need the force of 400 newtons for it to balance. So if here we have 400 newton, then this counter will balance. It will balance. Why? If we multiply this 400 times 2 will give us the moment of 800. Even here we have 800. So we can see that now the system is balanced. So the answer here is just B. Okay, so we move on to question 7. A dog running at a constant speed of 3 meters per second increases its speed to 7 meters per second upon seeing a lion. If the mass of the dog is 20 kg, the work it does in achieving the new speed is. So the whole focus is about the new speed. In order to achieve the new speed is. That is what we are trying to look for here. Now, we know that after just hearing these questions of what is the work done, maybe you may have the concept of work done is equal to force times the distance. Then you can see that we don't have force, we don't have that distance. Then you may start. Now, the point is, for a question like this, since we are looking at the motion, we are going to use the work done, we are going to use is equal to the formula for kinetic energy, where we have half multiplied by mass times the velocity squared. So we have half, then our mass, we know that mass is given is 20, then velocity, what are we going to do? So what we are going to do is we need to find the difference between these two numbers. So we are going to subtract 7 minus 3. So we can see that we are going to have 4 meters squared. Why 7? Because the increase in speed was just 4 meters. So that was the difference between the two numbers. So let's do mathematics here. 2 here is 1, 2 here is 10. So we have 10 times 4 times 4 will give us 16. If we multiply this, will give us 160 newtons. So our answer here is B. Though this question was a bit sensitive, but according to my understanding, this is how I'm understanding, I'm getting the concept of this. So since the question is all the work done in achieving new speed, so therefore the work that was done was to increase the speed of 4 meters per second. That was added because we know that 3 plus 4 we go to 7 meters per second. So that's my understanding. Then we have question 8. A thermal flask contains a vacuum. What is the purpose of the vacuum? So vacuum prevents conduction and convection. So the answer here is B. Okay, so now we can move on to question 9. Molecules of a liquid evaporates from a container and the temperature of the liquid left in the container changes. From which part of the body of the liquid do molecules escape, and what is the effect on the temperature of the liquid left in the container? So here we know that our answer may be C or D. Why? Because we know that evaporation only occurs on the surface of the liquid. So that is, now if we have this as our diagram, this is water. So we know that the only water that will undergo evaporation is this water here. So this the above water will be heated to a certain temperature. So as these water molecules are heated to a certain temperature, they will the temperature of these molecules on the surface will increase. Then during evaporation, when these water molecules evaporates, the remaining water the temperature will decrease, will be colder than the one that have escaped. So that is the picture. So the remaining molecules, after the other have evaporated, must also be heated so that they can also undergo the same process. So the key point is, after the molecules on the surface have heated and evaporated, the remaining temperature must decrease. So the answer is C here. Then in question 10, the diagram below represents a transverse wave between which two marked points is the distance equal to the wavelength of the wave. So the key point is we just want to find where we can see these two letters gives us a complete wave. So let's look at, if we look at BC we cannot have a complete wave. CG, we can see that if we are to connect this, cannot give us the half of the upper. But let's look at this one. So if we connect B up to G, we know that this part can fit on this part, so we can see that now we have a complete wave. So the answer is B and G, which is our C. So we move on to question 11. A lighted candle is placed in front of a loudspeaker that produces a loud, steady sound at regular interval. Okay, then what type of wave is produced by the speaker, and in which direction does it cause the flame? Does it cause the flame to tilt? So here we know that the type of wave is a longitude. Sound is a longitudinal wave, so it's either A or D. So then we can see that if these sounds were to be produced, they need to move in this direction. So we have our answer D here. Then in question 12, the diagrams below shows 3 rays of light incident on the boundary between a glass block and air. The angles of incidence are different. What is the possible critical angle? Now, for us to have a critical angle, we want the angle of incidence where the angle of reflection will be equal to 90 degrees. So whenever we have this incident like this one, where the reflected ray passes in the boundary just like this, then this angle is what we are solving for. This is what we call angle of the critical angle, which is CI. Now let's look at the first illustration. So we know that here, when this line is at here, we can see the reflected ray. Then we can see that the angle has decreased. Then we can see that there is a more, this ray of light has reflected more. Then when the angle has increased up to 50, there is what we call total internal reflection. So total internal reflection. So the angle that we are solving for is between this and this. Because if we increase up to 50, we have total internal reflection. Then if the angle is 40, we have at least refraction. So what angle is between 40 and 50? So we can look at the multiple choices. So the answer is B. Okay, so we move on to question 13. The diagram below shows an object placed underwater and being viewed from the top. Okay, so now let's look at what's the question. What is the refractive index of water? So let's go back to. So the distance from the surface of the water up to where an object is placed, this is what we call real depth. Real depth. Then the object seems to appear here, though the actual object is at here. So let's say this is our A, then this is our B. So the object appears to be at B. Then how do we define or find the apparent depth? So the apparent depth is the depth from the surface of water up to the point where the image appeared to be observed. Do not mistake 3.3 as the apparent depth. No, the apparent depth is considered or measured from the surface of water from here. This is from here up to where the object is seen. So for us to find this apparent depth, we need to subtract 3.3 from 14. Since we know that the whole distance is 14, so we'll say 14 minus 3.3, then we can my calculation is giving me 10.7. So this means that from here up to here is 10.7 centimeters. Then the refractive index, the formula is refractive index given the two distances will be real depth, then divided by the apparent depths. So what is our real depth? Real depth is 10.7 over, it's 14. Remember, the real depth is greater than the apparent over 10.7. So we can see that we can cancel this. Then 14 divided by 10.7. Then according to my calculations, I'm getting 1.3. And you can also commit this to memory. The refractive index of water is 1.3. Some books you may find it to be 1.33. So the answer is 1.3. So let's look at the multiple choice. So the multiple choice, since it was 1.308, so if we round it off, it will give us 1.31, which is our answer is A. Okay, so we move on to question 14. The diagram below shows a steel magnet being withdrawn from a coil of wire in the direction shown to a point as far away as possible. So we have a coil here. Then what is the effect on the steel magnet due to this action? So we have this movement. It's like they are pulling this bar magnet from the coil. Now the key point is we need to look at what type of current are we dealing with. So we can see that we are dealing with what we call alternating current. Then what is the effect of alternating current on a magnetized object? So the effect is it causes that particular magnet to be demagnetized, to lose its magnetism. So that's the effect. Whenever you see AC is used to demagnetize, while DC is used to magnetize. The reason why AC can be used to demagnetize a magnet is because it changes its direction. Because of that change in direction, it causes the domains. It causes the domains of a bar magnet also to point in a different direction. So the arrangement or the way domains are arranged in unmagnetized are like this. They are pointing in different direction. But if we have a magnetized object, the domains points in one direction. They have a uniform direction. So if we want to demagnetize this bar, we just have to disturb the arrangement of the domains, these domains. So how can we do so? We can just use the AC current. Why? The AC current changes direction. Because of that, it will cause the domains to point in different directions. So the answer is C, becomes demagnetized. Then we have our question 15. The diagram below shows an illustration of a transformer with 100 turns on the primary coil and 25 turns on the secondary coil. So the input voltage is 12 volts. We want to find the output voltage. So the question is, what is the voltage induced across the secondary coil? Okay, so we have the primary here, and also we have the secondary. So how many turns are on the primary? So on the primary we have 100 turns. Then on the secondary we have 25. So the ratio, if we were to change these into ratios, by what number can we divide by 100 to give us 25 is 4? So this means that 100 divided by 4 will give us 25. So if we have 12 volts here, then these 12 volts we divide by 4, because the proportion, they all follow the same proportionality. The number of turns, the proportionality followed by the number of turns can also be obeyed by voltage, including current. So since 100 divided by 4 is 25, then 12 divided by 4 will give us 3 volts. So our answer is 3.0. And it's making sense why this is a step down transformer. We can see that the input voltage is greater than the output voltage. How can we answer the same question? We can also find the same question like this. So we know that the 100 turns is equal to, so what do you do? Let's look at okay, yes, 25. Then here we have 12 volts. Then we can put x and we cross multiply. So this will give us 100x is equal to 12 times 25 over 100 over 100 is same as 25 times 4. So we can see that if we cancel this 25, 4 here is 1, 4 here is 3, we still get the same 3.0 volts. Or if you want, you can also, the formula, number of turns on the primary is over number of turns on the secondary is equal to voltage on the primary over voltage on the secondary. So number of turns we know on the primary is 100 over 25, then is equal to 12 over Vs. So we can see that we still get the same answer. So whichever principle, formula or method that you are going to use, the answer is the same, as long as you know how to use these proportionalities. So 25 into 25 is 1, 25 into 200 is 4, 4 into 12, we still get 3 as our final answer. Then we move on to question 16. The diagram below shows a positively charged rod placed close to two metallic spheres A and B, which are initially neutral. So at first, these two were initially neutral. So if these were neutral, this means that the protons and electrons were distributed evenly. So this means that in A, they were positive, minus, positive. Now, these were distributed evenly. Now, after this charged rod was brought closer to these two metal spheres, we can see that the charge on this one is positive. So what happens? What happens is the electrons from B will move into A. Why? So that because of the force of attraction. So these electrons in A and in B. So there will be electrons in A. We are just going to have electrons because of force of attraction. Now the protons in A will move to B because of repulsion. So B will only have positively, which are protons. So the key point here is the answer is B. A has gained electrons from sphere B. Okay, we can now continue. So question 17. The diagram below shows a circuit with 4 ammeters connected at different positions and 3 resistors of different values. Which of the 4 ammeters, labeled A, B, C, or D, would show the largest reading? So what this question is here is, we want to determine the ammeter where we think we are going to have the largest current. Now let's look at ammeter A. Ammeter A is only measuring the current that is passing through this resistor 1. Ammeter B is measuring the current that is passing through resistor 2 and resistor 3. Ammeter C is only measuring the current that is passing through resistor 3. Then if you look at D, so let's look at the pattern. If current is coming at this junction, what happens at this junction? We'll call this junction, let's say X. So a certain amount of current will go to this. Then the remainder of that current will proceed. if this is our junction Z, from the remainder of that current, another amount of current will move in this direction, then the remainder will move in this direction. So the movement of current to each resistor depends on the size of the resistor. The higher the resistor, the lower the current, because we know that these two are inversely related. So we can see that A is measuring only part, B is measuring only part, C is measuring only part. But if we continue, the same current that moved, we are going to have this current, then also we are going to have this current. So these two current will join to form one. So this current here is equal to this current at B. Then this current after passing through resistor 1 will join with D. So the current at D is the greatest because it involves the three currents here. So the answer is D here. Then we have question 18. A secretary in a manager's office uses the following appliances with respective power ratings. So electric kettle 1200 watts, printer 600 watts, computer 100 watts. Given that the cost of electricity is 0.80 per kilowatts hour, calculate the cost of operating all the three appliances at once for 12 hours. So what's the formula? So the formula is cost is equal to, we need to have power. Make sure your power is in kilowatts times time. Make sure your time is in hours. So if the question is for 2 days, make sure you convert 2 days to hours. Then multiply by cost per unit. So let's add these watts. So 1200 watts plus 600 plus 100. So we can see that the total is 1900 watts. Now we don't want this watts, this power in watts. We want it in kilowatts. So how do you convert from watts to kilo? You divide by 1000. So 1900 divided by 1000, this will give us 1.9 times the time is given 12 hours. Then the cost is also given 0.80. So let's do 1.9 times 12 times 0.80. So I'm getting 18.24 as the cost. So our answer here is just D. Then question 19. Which of the following is correct about the purpose of X plates and Y plates in a cathode ray oscilloscopy? So I'm sure you've at least come across this structure here. This is a cathode ray oscilloscopy. Under a cathode ray oscilloscopy, we have this, what we call a cathode, and the function of the cathode is it produces a beam of electrons when it is heated, and the process is known as thermionic emission. So thermo-ionic emission. Then we have the other structures like the anode. The function of the anode increases the speed of the beam of electrons. Then we have a grid. The grid helps or focuses the beam of electrons in one direction. Then we have the X plates. Then the X plates are like this. Then we also have the Y plates. So we have the Y plates. These are Y plates. These are X plates. Now what is the function of the X plates and the Y plates? So the X plates deflects the beam of electrons horizontally, the Y plates vertically. So the answer is C here. Okay, so we move on to question 20. The diagram below shows a box used for storing radioactive sources. Which material is best for lining the box to prevent the escape of most radioactive emissions? So let's take it for instance that here we have radiations like alpha, then we have beta, then let's say we have gamma. So in order to prevent these radioactive radiations from escaping, we need a material that can protect the O3. So from these multiple choices or given list of metals, it's just lead. So that is our answer there, because the remaining may just protect two, the other one can pass through. So we are done with section A. Let's look at section B, 45 marks. Answer all questions in this section. Write your answers in the spaces provided on the question paper. So B1, figure B1 shows part of a vernier calipers. Okay, so the question A is, what is the reading of the vernier calipers? Okay, so how do we determine the reading? So there is always this line where we have a 0. So the point is we need to know the position of this small line here, which is before this line where there is 0. So that's our focus here. Now we can see that if this number is 8, then the number here, it was 7. So if here we have 8, then this should be, if we have, let's say, 7.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, so this is 7.9. Now 7.9 is in centimeters. Now let's say we want to give it in millimeters, so this will be 79 millimeters. So how do we convert from centimeter to millimeters? You multiply by 10. So this is what you do under the main scale. So the first one, you need to find the readings in the main scale. So you find the reading the main scale by looking at this point before 0. So in main scale, we have 79 millimeters. Now we move to vernier scale. Now vernier scale, if you look at the vernier scale, there will be a line that will coincide. What this means is there is a line that meets with the above line with the below line here. There is one line. The other remaining lines, you see that they are not connected with each. So that line that is coinciding is what we are interested in. So we can see that this is our line of interest. So if we can see that if this is our 0, 1, 2, 3, 4, we can see that this line is only 5. So on the vernier scale, we have 5 multiplied by 0.1. This will give us 0.5 millimeters. So the reason why I wanted this in millimeters, so that we can have the same readings in millimeters, so that we can just add. So 79 plus 0.5, then our final answer here will be 79.5 millimeters. So this is how you can find the reading. And for those that may want more of this, feel free to write your comments in the comment section below. I will see what I can do for that. Now let's move on to question B. Write in words the standard international units of the following physical quantities and state their symbols. So velocity is meter per second. So we have meter per second. Then in symbols, this is meter per second. Then the temperature is Kelvin. The SI unit for temperature is Kelvin, not degrees Celsius. Then we have K. For acceleration is meter per squared second, or per second squared. So meter per squared second. So that's what they wanted for this question. So let's look at the next question. Okay, so for question 2BA, what is the difference between density and relative density? So we know that density is the mass per unit volume, whereas relative density is a density of a substance compared with the density of water. So the key point is the relative density is just a ratio. So the formula is like this. So relative density is equal to, so you need to say density of a substance over density of water. So let's say if we have 10 grams per cubic centimeter as the density of a given substance, then our relative density will be 10 grams per cubic centimeters over the density of water is 1 gram per cubic centimeter. So we can see that this will cancel. So our answer is just C, 10. So relative density is initially a ratio. Now we move on to question B. Figure B 2.1 shows a cuboid containing water, cuboid container that has a 5 centimeter square base and contains water to a height of 60 centimeters. Now let's look at the first question. What is the volume of water? So this question, we need to find the volume by using the formula. So we can see that the base is the square. So this means that we have two distances that are equal, then our height is 6 centimeters. So the formula will be L times height. So I'm sure some of you may remember this formula, L times B times height. You use this formula if you have the two base distances that are different. So means one is length, the other one is breadth. Now for this one, we can see that we have the same base distances. So one will be 5 centimeters multiplied by another 5 centimeters. The height is 6 centimeters. So 5 times 5 is 25 times 6. We will see that the volume of water will be 150 cubic centimeters. Then question 2, a stone is immersed into the water in the cuboid, causing the water to rise to a height of 8 centimeters. Determine the volume of the stone. So under this one, this is like now the volume of a stone will just say an irregular. So the key point is, how do you find the volume of an irregular object? So we are going first to find the final volume. Then the final volume, we subtract it by initial volume. So the initial volume is the volume of water before the stone was immersed. So let's go back, we find the final volume. So what's our final volume? If we are to draw a new diagram so that we may have a picture, I like having a pictures because it makes the school stuff to make sense. So I want to see if I can give you the picture of what is happening here. So after the stone is immersed here, we are told that the water rises to a new height. So the new height is 80 centimeters. Now the question is, did the base change? No, the base still remains 5 centimeters multiplied by 5 centimeters. So we can now find the new volume. So it will be L times H. What's our L? Is still 5 centimeters times 5 centimeters. Then here we multiply by 8 centimeters. So 5 times 5 is 25. 25 times 4 is 100. Another 100 will give us 200. So the volume 2 is 200. So in this 200, it means that there is the volume of water and the volume of the stone. So how can we find the volume of the stone? We know that the volume of just water is 150. So if we subtract 200 minus 150, then we have the volume that we want. So that's the concept that was required here. So we know that the final volume is 200 cubic centimeters minus 150 cubic centimeters, which is our final answer, is 50 cubic centimeters. Now let's say maybe we find the same answer. Okay, so volume is equal to L times H. We know that the height to which water rose to was 8 centimeters. 80 centimeters. Then the height of water is 6 centimeters. So this means that the height by which the water rose when the stone was immersed was just 2 centimeters. So we can say we know that the base is not changing. 5 times 5 times 2. 5 times 5, 25 times 2 is 50. So this is also how we can find the volume of the stone. If we are given an illustration like this one. Then we move on to question C. If the mass of the stone is 80 grams, calculate the density of the stone. So we know that density is equal to, we have mass over volume. What is our mass? 80 grams over 50 cubic centimeters. So we have 80 divided by 50. So my answer is 1.6 grams per cubic centimeters. So this is our answer, 1.6 grams per cubic centimeters. So we move on to question 3. Figure B3.1 shows a ramp being used to lift a box weighing 480 newtons through a distance of 3 meters and a height of 1 meter by applying a force of 200 newtons. Now question A, state the meaning of the term simple machine. So say this is a device in which less effort is applied to overcome a huge load. But in simpler terminologies, a simple machine is just any device that makes work to be easy. Now for question B, we want to find the mechanical advantage. So the formula for mechanical advantage is equal to load over effort. So the load represents the weight of an object. Then the effort is the force that was applied. So a machine cannot work without the effort. So we need to apply effort. So let's look at the question. So a box weighing 480 newtons. So this is our load because this is weight. Then the force that was applied for this to move, there was a force of 200 newtons to push the box. So this is our effort. So we are going to have 480 divided by 200. So if we cancel, we are going to get 2.4 as our mechanical advantage. Remember, mechanical advantage is a ratio. We don't have to put the units. Then if we look at question C, we want to find the efficiency. So the efficiency is mechanical advantage over velocity ratio, then multiplied by 100%. Mechanical advantage, we have it is 2.4 over. Now here we can see that we still have some work to do. We need to find the velocity ratio. Now how do we find the velocity ratio for an inclined plane like this? So it's different from the pulley system where we just count the ropes. So here velocity ratio is equal to L over H. Now L is not the load. No, this time L is, we'll just say, a slanting distance. So a slanting distance. Then our H is just perpendicular height, the height against the gravity. So the slanting length is this distance, and we can see that we have 3.0. Then the perpendicular height is this one, where the height that moves against to gravity, so which is 1.0. So if we cancel this, we can see that our velocity ratio is 3. And remember, velocity ratio must be greater than mechanical advantage. So if we do mathematics here, 2.4 times 100 will give us 240 percent over 3. 3 into 24 will give us 80. Then so the final answer is 80%. So that's how we can calculate the efficiency, and we can see that 80% in terms of the efficiency is at least a good number. We can see that at least there is only 20% in terms of loss of energy. Okay, we can now move on to question B4. Figure B 4.1 shows a glass syringe with a sealed tip containing a gas at an initial pressure of 360 Pascal placed in hot water. After a few minutes, the piston in the syringe moved up. Then question A, using the kinetic theory, explain why the piston in the syringe moved upwards when the syringe was placed in hot water. Okay, so let's have a picture here. So say this is our piston before placing in hot water. Now after placing it in hot water, we are told that the piston moved up. So you can see that the piston is somewhere here. So the question is, what is happening to the gases inside? So since we are saying we are placing it in hot water, so hot water, we can see that the temperature is high, and we know that temperature, the hot temperature, is about the average kinetic energy. So what happens to the particles after gaining a certain amount of energy, or after increase the temperature? So what happens is the particles inside will gain kinetic energy. As a result, they will start to move very fast. Now because of that, they will force the piston to move. So because of the energy, we are saying the particles will start repelling against each other. Because of that force of repulsion between the particles, the piston will be forced. Now to simplify this, we are saying whenever we increase the temperature of a gas, the gas particles will gain kinetic energy. As the result, the volume will increase. As the volume increases, the pressure decreases. Thus, the relationship between volume and temperature is they are inversely related. So we'll say when the temperature of a gas increases, increases, the gas particles will gain kinetic energy, and spread out So the spread out will now force the piston to move, or will result in an increase of volume. Now, question B, the piston was pushed down to 20 cubic centimeters while the temperature remains or is kept constant. In terms of the kinetic theory, explain why the pressure of the gas in the syringe increases. Okay, so we are saying if we have the same number of particles, now we push the piston, we push it down, we push this piston. So you can see that the particles, the volume inside is reduced. It has reduced. Now, because the volume has reduced, the particles have come very close to each other. As the result, here we are going to have a very high collision effect. So because they are easily colliding with each other, the pressure will increase. So the point is, if you force the particles to come closer to each other, the volume or the size of the space will reduce. Then the decrease in volume or the size of the space results in an increase in pressure. What is pressure? Pressure, according to kinetic theory here, is just the collision of the particles with each other and against the wall. So whenever we bring the particles closer to each other, there is the high chance of the particles to collide with each other. So to summarize here, we are saying if you decrease the volume, the pressure will increase. So we'll say the reduction of the volume forces the particles to come closer to each other, thus an increase in pressure. So the other point is, sometimes you may be asked to what is the relationship between volume and pressure. And gas laws is that these two are inversely related. If one increases, the other one decreases. Now, let's go back to the statement. So we know that before the movement of the piston and the placement of this into this, the pressure was 360. And the volume, we can see that the piston is here. So the volume is at 60 cubic centimeters. So this is our initial volume. Now, after this piston has been pushed to 20, what is the pressure? We know that if we push this piston to a 20 cubic centimeters, the particles will come very close to each. As a result, the pressure will increase. So here we are expecting to have a number greater than 360. So how can we find this, and which law are we looking at? This is the Boyle's law. Now, for some people, it may be a challenge to master the formula, and so what I can just want you to master is, I want you to master this. PV is equal to T. With this, you can derive any formula that we want. Okay, I will show you. Let's say from this question, we know we have been given while the temperature is kept constant. So if the temperature is constant, let's make temperature the subject of formula. For this one, we know that the temperature is already the subject of the formula. So what are we supposed to do? Where there is temperature here, where there is T, we are going to put the exact T on the left side. So PV is equal to PV. So we'll say 1, 1, 2, 2. This is the formula that we are going to use. So what's our pressure 1? Remember, pressure 1 is 360 Pascal. Volume 1 is 60 cubic centimeters. Pressure 2 is what we are solving. Volume 2 is 20 cubic centimeters. So we know that we can just divide by 20 cubic centimeters. Also here by 20 cubic centimeters. So that if we cancel this pressure 2 is this will cancel here, 2 here is 1, 2 here is 3. 3 times 0 is just 0. 3 times 6, 18 carry 1. 3 times 3 is 9 plus 1, 10. So this is our new pressure, and it's making sense. We can see that pressure 1 is 360 Pascal. Pressure 2 is 1080 Pascal. So you can see that the pressure increased. What is volume 1? Volume 1 is 60 cubic centimeters. What is volume 2? Volume 2 is 20. So you can see that pressure increased, volume decreased. That's why pressure is related inversely to volume. If pressure increases, the volume decreases. If the volume increases, the pressure decreases. So if maybe the question was, can you state this law, which is Boyle's law? From the calculations, if for instance, let's say you've forgotten to state the law that you are looking at, you can state the law based on the calculation. So whenever you see that one factor increases, the other factor decreases, then you just know that from the law, you are just going to say they are inversely proportional. So how can we state this one? We can just say the pressure of a fixed gas the pressure of a fixed mass of a gas is inversely proportional to volume, provided that the temperature remains constant. So let's see the point here. Now, away from there, let's say we want to make the formula. Let's say if now pressure is what is constant. If pressure is what is constant, let's make pressure the subject formula. So we divide by V, also here by V, so that if we cancel, P is equal to T over V. Where there is P, we put this. So our formula would be T over V is equal to T over V. So 1, 1, 2, 2. This is another formula. So from the question, you'll be given this remains constant. So make that as a subject, then you'll be able to see the formula. Then also don't forget that T over V1 is same as V1 over T1 is equal to V2 over T1. These two formulae are the same. Then you can also make the other one. If V is what is constant, you make V the subject formula. So PV is equal to T. The key point is just master this. So if what is V is what is the subject T, if what wants the subject, so divide by P, also by P here. So V is equal to T over P. So T over P is equal to T over P. So 1, 1, 2, 2. Or P1 over T1 is equal to P2 over T2. So these are the three formula. We have Charles' law, Boyle's law, Lussaki's law. Then the ideal equation, we know that all the three will change. So that one is PV over T is equal to PV over T. Then you give them the numbers according to where they are. Okay, so now we move on to question 5. Figure B5.1 shows various regions of the electromagnetic spectrum. Then, okay, so here under this spectrum, you need to know how these electromagnetic waves are arranged. You need to look at the order, then the wavelength, including the frequency. Now, you need to find ways of how do you remember this, but we have a common mnemonic that we use. So we say we use ranging Martin's invaded Venus using X-ray guns. So what this means is R is for radio wave. So this means that here we have radio waves. Then M for Martin is here. M is for M is microwaves. Then I is here, infrared. Then V is for visible light, we have it. U for ultraviolet. Then X-ray is just X-ray here. This is our X-rays. Then guns, we have gamma rays. So we are saying ranging Martin invaded Venus using X-rays guns. So you can use this to master the arrangement of these waves. Now let's look at question A. What is the name of component N? So N is just the X-rays. Then give one practical use of region M. What is M? Infrared. So the first one, it is used in remote controllers. Then also it is used in heaters. Then also it is used in like for night vision. All these are uses of infrared. Step 1 property, which is the same for all electromagnetic waves. So the property is, we know the first one, they are all transverse waves. So that is our first property. So I just want to give you more of this in case you are asked to give 2. Then the second one, they travel at the same speed. They travel at the same speed of light. We know that the speed of light is 3 times 10 to the power 8. So these travel at the same speed. Then the other one, they carry energy as they move from one point to another. They carry energy. Then the other one is they can travel in a vacuum. They can travel in a vacuum. Then state one possible source of the radiation from region E, or what's O. Or we said it's a gamma. So the source is the first one, nuclear reactions. Then also explosions on the sun. Then let's go to question 6. Figure B6.1 shows a converging lens of focal length 2.0 centimeters used to produce an image of an object 2.0 centimeters tall, placed 5 centimeters from the lens. Using the information given above, draw to scale on figure B6.1 array diagram to locate the image formed. So whenever you are taught to draw to scale, you need to make the measurements using the rule. So make sure you use the rule. So what is our first step? We know that the focal length is given 2 centimeters. So from the lens here, where we are going to have f1, make sure that the distance here is 2 centimeters. If this is 2 centimeters, each focal length will be 2 centimeters. So here we are going to have 2f. So 2 centimeters. If we have 3f, make sure that each focal length is equal to 2 centimeters. Then this also must be made sure that it has to be done on the right side also. So also here it's 2 centimeters. Then here we have 2f. So after we are done writing the focal length, we can now look at the position of an object. So the position of an object is 5 centimeters from the lens. So we see that we know that each focal length is 2 centimeters. So 4 is here, 5 is in between here. But the good part is just get the rule, measure 5 centimeters from where the lens is up to here. So this is where our object is expected. So this is our object. Then make sure that as you are measuring, writing the object, make sure that the height is also 2 centimeters, because we are given 2.0 centimeters tall. So that should be the height. So the distance of an object is 5 centimeters. Okay. So what is our first step? You need to draw a straight line parallel to the principal axis. Then upon touching the lens, you need to bend, passing through the focal point number 1. So make sure you draw these lines freely. Then from there, you draw a line that will pass through the optical center. So as you are drawing, these two lines will meet on their own. Do not force them to meet. They are going to meet on their own. So the point where these two lines meet is where our image is expected to form. So we have done we've drawn this image. And remember, the distance from where the image is and the lens is the distance of an image here. Then calculate the magnification of the image formed. So for us to find the magnification, first we need to have the distance of an image. So how can we find the distance of an image? We are going to use the lens equation. So the lens equation is 1 over f is equal to 1 over do plus 1 over plus 1 over this is di. So 1 over 2 is equal to 1 over distance of an object is 5 plus 1 over di. Then here we can shift this number to here. This will give us 1 over 2 minus 1 over 5 is equal to 1 over di. Lowest common denominator is 10. 2 into 10 is 5 times 1. Here is 5 minus 5 into 10 is 2 times 1 is equal to 1 over di. 5 minus 2 will give us 3 over 10. 1 over di. We cross multiply. 3 times di will give us 3 di. 10 times 1 is 10 over 3 over 3. So 10 divided by 3 will get 3.33. And this is making sense. We can see that the distance of an image for this diagram is less than the distance of an object. So this means that we have the distance of about 3.33. So after we have this distance, we can now say magnification is equal to the distance of an image over the distance of an object. Distance of an image is 3.33 over 5. So 3.33 divided by 5 will give us 0.66, which is 0.7. So whenever you have magnification as 0 point something, just know that the image in terms of the height or the size is lower than an object. So that is the key point. Or we can just see that here, the some of the points that we need to have in mind is whenever we place an object beyond 2f, the image will be formed between f and 2f on the other side, upside down. Then the image will be smaller than the object. The distance of an image will also be smaller than the distance of an object. So that is what we can do here. So let's say we want to do this, simplify this number. We don't want to. So what we can do is we can multiply everything by 2 times 5 times di. So multiply this, so know that if we multiply 1 over 2 times this same as 1 over 2 times 2 times 5 times di. So this will cancel. We are going to get 5 di. Then if we cancel this and this, so this is same as 1 over 5 times 2 times 5 times di. So this will cancel. This will give us 2 di plus 1 over di times 2 times 5 times di. So this and this will cancel, will give us 10. Then we correct the right term, so this will be 5 di minus 2 di is equal to 10. Here we have 3 di is equal to 10 over 3 over 3. We can see that di is equal to 3.33. So my point is, if you don't want to use this principle where you are dealing with fraction, because for some people calculations that involves fractions may seem to be tedious for them. So for those that may have those challenges, you can use the other principle. Okay, so we move on to question 7. Figure B7.1 shows magnetic field lines between the poles of 2 magnets. So we know that a magnet has 2 poles. There is a north pole and there is a south pole. Then always we know that the magnetic field lines run from north pole to the south pole. So always just master the direction of the magnetic field line. So whenever you see the originating of those is the north pole. So here we can see that if we have this arrangement here, if whenever you see these magnetic field lines are moving from one magnet to another, this shows attraction. Then this diagram is repulsion. Now we can see that the direction of the magnetic field lines will show us this is our north pole, this is also north pole, this is south pole, this is also south pole. Then the question is name the point R, this point here. This is known as the neutral point. It's neutral. Nothing is felt at this point because of repulsion. So here we have neutral point. Okay, then if P is south pole, okay, what are the poles Q? Q we know it's north pole. Then what is our T? South pole. Okay, so move on to explaining how soft iron keepers help magnets retain their magnetism for a longer period of time. So here we can we just say, so say a soft iron keeper, no say, okay, let's say piece called D a keeper is placed across across the pores. Then you say this soft ion piece provides a path for magnetic field lines, to form a continuous loop. Then for question D, state two differences between iron and steel as magnetic materials. So two differences between iron and steel. The first one also, iron is a soft magnetic material, whereas steel is a hard magnetic material. So that is the first difference. Then the other one we can see, iron is easy to be magnetized. Wow. Whereas steel is hard to be magnetized. So in terms of strength retention, steel has a high strength retention. It keeps the magnetism for a longer period of time compared to iron. Okay, so we move on to question 8 here. So question 8, figure B 8.1 shows 3 resistors connected to a 12 volts battery. Calculate the effective resistance between X and Y. So I'm sure the X should be here and Y should be here. So we can see that we have these two resistors that are connected in parallel, and the formula for total resistance is 1 over RT is equal to 1 over R1 plus 1 over R2. So 1 over RT, 1 over 12 plus 1 over 6. What is our lowest common denominator? Is 12. 12 into 12, 1 times 1 is 1 plus 6 into 12, 2 times 1 is 2. So if we proceed, we'll get 1 plus 2 will give us 3 over 12. We cross multiply. 3 times RT is 3 RT. Then here we are going to have 12 over 3 over 3. So RT is equal to 4 ohms. This means that if we combine these two resistors, they will form one resistor with 4 ohms. Now let's say we don't want to use the fraction, so this is 1 over RT is equal to 1 over 12 plus 1 over 6. So we're saying we multiply by RT times 12 times 6. So begin with this one. So that 1 over RT times RT times 12 times 6. So this will cancel. Then we are going to have 12 times 6. So 12 times 6, I'm getting 72 here. Then we'll move on to the next one. 1 over 12 times RT times 12 times 6. So this will cancel. This will give us 6 RT plus 1 over 6 times RT times 12 times 6. So 6 will cancel. This will give us 12 RT. So 72 is equal to 12 plus here will give us 18 RT over 18 over 18. So 18 into 72, we are still getting 4. So we can do these calculations. So what this means is if we were to redraw this circuit diagram, it is like this. So we know that here we have 2 ohms. Then these 2 resistors have been combined to form 1. So we are like this now. So here we have 4 ohms with 12 volts. So we had the amount for our connection. So this is parallel here. Then if we combine these, we can see that we have now a series here. A series. So let's look at the next question. The current flowing in the battery. So we just want the total current of the circuit. So the formula is current is equal to voltage over total resistance. Okay, so what's our total resistance? So the total resistance is, we want now to combine all the resistors so that we may have 1. We know that here. So how can we combine these two? So we know that these two are in series. So we just have to say resistor 1 plus resistor 2. Resistor 1 is 2 plus 4. This will give us 6 ohms. So that's our total resistance of the circuit. So voltage we know is 12 over 6, which is 2 amps is our final answer. The current flowing through the 6 ohms resistor. So we know that current is equal to voltage over resistor. So let's go back to our diagram. So we want the current in 6, the current that was, we know that the total current is 2. So we want to know how much from 2 will go through 6 resistors. So let's go back to here. We know that the source, that the voltage that is produced is 12. So at this point we have 12 volts. So from 12 volts, how much of voltage is used by the 2 ohms? So say voltage is equal to current multiplied by resistance. So current we know is 2. The resistance here is 2. So this means that from 12 volts, this is just using 4 volts. So here we only have 80 volts. So we know that under the parallel, here we are going to have 8 volts. Also here we are going to have 8 volts. Why? When a circuit, when 2 resistors are connected in parallel, they have equal voltage. So this will be the voltage we know is, the voltage is 80 over 6. So what is 8 divided by 6? So it's 1.3333, which is 1.3 current amps. Now if 1.3 is going through, if is going through the, what's this, the 6, what is the current that is going through the 12? So to find that, we can just say total. We know that the total current is 2, so 2 minus 1.3 is 0.7, but we can also find the same 0.7. We can say current is equal to 8 over 12. So what is 8 divided by 12? It's 0.66, which is, if we round off, is 0.7. We know that if we add these two, must give us to this the total current according to the Kirchhoff's loop law. Then we go to the last question for section B. Polonium 210 as mass number 84, atomic number can undergo radioactive decay by emitting an alpha particle to form lead. Then what is an alpha particle? So it is a particle with 2 protons and 2 neutrons. Then write the equation for the radioactive decay. So we have PO 210 as our mass number 84. So under alpha decay, the mass number will reduce by 4 units. So 210 minus 4 will give us 206. 84 minus 2 will give us 82. Then we have been given the daughter. Then plus this nuclide for alpha. Set one use of alpha radiation. So to treat cancer cells. Okay, so now let's maybe see if we can share 1 or 2 from section C. Answer N2 questions from this section. In the answer provided, an automobile of mass 200 kg started from rest position and increased its speed uniformly to 9 meters in 30 seconds. It maintains this speed for another 500. Sketch the speed time graph of the automobile for the journey described. So here we just want to sketch. So let's draw this line here. So this is our XY plane. So here we are going to have time. Then here we are going to have speed. Okay. So the first point is we are told started from rest position. So whenever we have rest position, it means we are going to have 0 here. Then how many seconds? We can see that it increases its speed uniformly to 9 meters per second in 30 seconds. So whenever we have uniformly, we need to draw a straight line, or we have a constant acceleration. So this means that this reached the speed of 9 meters per second. Then that speed was covered in a time of 30 seconds. We are given that. Then the other question is, it maintained this speed for another 500 seconds. So this means that we are going to draw a straight line parallel to the x-axis. So here, what are we going to have? We are going to have 530, because we know that from here up to there is 500 plus this 30. So we have done, we have sketched. Then for B, calculate the uniform acceleration of the automobile. So acceleration is equal to final minus u over t. Final velocity is 9 minus 0 over the time is 30. So 9 minus 0 is 9 over 30. So what is 9 divided by 30? 0.3. So 0.3 meters per second squared is our acceleration. Then question C, how much force was required to produce this acceleration? So here we are going to use the Newton's second law of motion. Force is equal to mass by acceleration. Where is mass? We have the mass is 2000 kg. So 2000 times 0.3. So we know that we can cancel this 0. So our answer is 600 newtons. Or you can just see punch it on a calculator. Then D, calculate the distance covered by the automobile when it was moving at constant speed. So this point up to here is where we have constant speed, since this is a speed time graph. So we can now shade. This is the distance that we want. So we can see that this is the longest length or distance, so this will be our L. Then this is the shortest, or the shorter than this one, this will be our B. So distance is L times B. What is L? So L is the difference between 530 and 30, so which is 500 times 9. So 5 times 9 is 4500 meters. So this is our distance. Then E, what was the average speed of the automobile for the journey described? So average speed, we know that we need total distance over total time. So we can find the distance for this one. So this is a right angled triangle. Then this will be our height here. Then the distance, we know that the distance is equal to half BH. Half our B is here, 30. Then our height is 9. So we have 15 times 9. So 15 times 9, I'm getting 135. So 135 is the distance for the triangle. So the total distance is now 4,500 plus 135. So I'm getting my total distance as 4,635 over the total time taken is 530. So divided by 530, I'm getting 8.7 meters per second. So this is what I can share with you for this question. So let's check for question 2. Table C2.1 shows a table with corresponding values of potential difference across a torch bulb and the current flowing through the same torch bulb. Using the correct circuit symbols, draw a clearly labeled diagram of a circuit which could have been used to obtain this data. So we have been given a bulb. This is our bulb. Then here we are going to put our ammeter. Ammeter must be found where there is the positive terminal. How do you know that this is our positive terminal, where there is this longer one than this? Then we are told the corresponding values of potential difference across a torch bulb and the current. So our key point is we want to measure the voltage for this one. So we know that voltmeter is connected in parallel. Then we can say we may have our switch here. So this is the diagram so far. Then on the graph paper provided and using the data in the figure above. Okay, so let me just, now here I don't have a graph paper, but let's do this. You can use the graph paper. So I will just use these numbers to determine the type of the curve that we are going to have. So we know that resistance is equal to voltage over current. So I want to find the resistance at this point here. So this will be 0.20 divided by 0.40. So my resistance is 0.5. Then let's check for this one. So for this one will be 1.0 divided by 0.8. So it's 1.25 here. Then here we have 5 divided by 1.20. 4.0. So we can see that the resistance is increasing. So now, since the resistors are not the same, when you plot that graph, you are not going to have a straight line. So you may have maybe something like this. So how do you know that you are going to have a straight line? We need to have the same resistor if we are to find that. So that's what you're going to use there. Then for C, from the graph, set whether or not the filament of the bulb, touch bulb, is an ohmic conductor. The answer is this is not an ohmic conductor. Why? The line will not be straight. So that is what you are going to say for C. You are going to say the filament is not an ohmic. It did not obey the Ohm's law. For us to have an Ohm's law, we need to have a linear line or a straight line. So you say the filament is not an ohmic conductor because the resistance was not constant. The resistance kept on changing. Then D1, using the graph you have drawn to determine the value of the potential difference across the torch bulb when the current flowing through it is. So from this, using the data, plot the graph of current on the X. So the current is on the x-axis here, then potential difference voltage is on the y. So what this means is you need to go where there is 2.6. If 2.6 is here, you need to go where there is 2.6. You move parallel to the y-axis, then upon touching the curve, you also turn 90 degrees moving parallel to the y-axis. So at this point is where you're going to get the answer. Then calculate the resistance of the touch bulb. So after you found the voltage here, you calculate that resistance using 2.6 current is given. So the voltage at this point divided by 2.6 will give you the resistance. So that's what you can solve for this question. Then for question C3, a radioactive element with mass number 22398 emits one beta particle followed by two beta particles. One beta particle. So this means that we had 3 emissions of beta particles. What is a beta particle? So it is a particle. It is a particle with 1 electron. Then write the nucleon number and photon number of the remaining nuclide after the 2 emission. After the 2 emission. So the 2 emissions, we have the first one here. Then so here the question is still 3 emissions. So let's look at the first one. X22398. So what happens if it emits beta particle? So we know that the mass number will remain the same. So we're going to have 223. Then the atomic number will increase by 1. So we'll say this is our Y plus C. Then the nuclide for beta. Then Y will become our parent. What happens to the mass number will not change. Then the atomic number increase by 1 to give us Z plus E 0. Okay, then the last one we're going to have Z with 223 100. The mass number will not change. The atomic number will increase by 1. Let's say forming A plus C, the nuclide for beta. So after 3 emissions, this is what we are getting here. So the question is, we want to find the nucleon number. So nucleon number is the same as the mass number. So the mass number is still 223. Then the proton number will be 101. So the proton number is just the number here. Then let's look at what else do we have. A 400 grams radioactive sample has a half-life of 4 years. On a graph paper, plot a graph to show this decay curve after the period of 32 years. So let's do this. So we'll say time, then we'll have mass here. So the time 0. When the time was 0, the original mass was 400 grams. So this means that after 4 years, half of it must decay. So after 4 years, we are going to have 200 grams. After 8 years, half will decay 100 grams. After 12, we are going to have 50 grams. After 16, we are going to have 25 grams. Then after 20, we get 12.5 grams. After 24, so 12, we are dividing by 2. So 12.5 divided by 2, we get 6.25. Then after 28, we get 3.125. Then after 32, so I'm getting 1.5625. So the key point is after 32 years. Now on a graph paper, that you are supposed to do is, what you are supposed to do is, you need to draw the XY plane. Then in x-axis, we can see that we have 0, 0, 4, 8, 12, 12, what else? 16, 20, 24, 28, 32. So we'll say time. I know that our time is in years. Then this point will say 50. 50 can, yes, 50 can fit. So 50, 100, 150, 200. Then 250, can this fit? 250, 300, okay, let's just say 100. So we'll say 100, this is 200. Then here we'll say 300. Then here we are going to have 400. So in y-axis we'll just say 2 centimeters represent 100. In x-axis we'll say 2 centimeters represent 4. So the first point that we are going to plot, we can make the table of values. So here we have time in years. So 0, 4, 8, 12, 16, 20, 24, 28, 32. Then we have mass. So the first 200, 400, I mean 200, 100, 50, 25, 12.5, 6.25, 3.125, 1.5625. So 0,400 is here, 4,200 is here, then 8,100 is somewhere here, 12,50 here, 16,25 somewhere here, 20,12.5. So the curve will move closer and closer to the x-axis. So this is our curve. This is the picture that we are going to have here. Then Roman number 2, what period of time would it take for the sample to reduce to 40 grams. So here, if this is our 100, so here we have 50, so 40 is somewhere here. So what you are going to do is you need to draw the way we did or we do on the statistics. So you need to draw a straight line where there is 40 in x-axis, in y-axis. Then you draw a line parallel to the x-axis. Upon touching the curve, you move down. So this is where our point is. So for you that are using the graph paper, you'll be able to get the actual answer. Name a source of gamma radiation. So gamma radiation, which is gamma rays, the source of, we say, the nuclear reaction. So this is what I can share with you guys. So that's it for this video. Thanks for watching.